dog can watch. Dogs actually watch movies. Like, it's hilarious. I've seen my dogs like so into like Lion King and like they're just like sitting in front of the TV. No, like they like, actually sit in front of it. They're just like this.
Wow.
Like my dog will literally watch. I know. It's not like. I'm like, I didn't teach you that. What did you say? They just kind of like watch the people. I think it's fun. Like, yeah, specifically with animals though, they like pay more attention. But one time she was like laying down.
All right, guys. Let's go ahead and jump in. We have learned what polynomials are. We've added and subtracted polynomials. We've multiplied polynomials. We've factored polynomials. The last thing we do in this unit is divide polynomials. In fact, we look at them when you have one polynomial divided by another polynomial, you look at it as a fraction. So let's go ahead and let's start right here. A rational expression is simply an expression that is written as a fraction. Rational expressions can definitely include polynomials. So we have to go back before we begin with polynomials and see what do we know about simplifying fractions. You all, I would hope you all know that this fraction simplifies, but the question is why? There's a GCF. What goes into both 24 and 9? 3. Good. In fact, I could write this as 8 times 3 divided by 3 times 3. And now I can see that 8/3 times 1, because any number divided by itself is 1, will reduce to 8/3. So yes, 24/9 simplifies to 8/3. The reason why is because there was a common factor in the numerator and denominator. So let's go ahead and let's write the reason why. Why you can reduce a common factor from the numerator and denominator. Now, yes, factor, that's a really, really, really important math word in this lesson. Does anybody know what a factor is or what it's defined as?
Like when I think of like factor, I think of like contributes to something.
Contributes, I like it. Contributes, if we think about it in like using part of, I like it. Specifically, we could use the word contributes by multiplying. A factor is something that's been multiplied. So if you can reduce a number or an expression that's been multiplied to the top and the bottom, that's when you know that it can be simplified. So let's go ahead and see, now that we look at some polynomials, which of the following illustrate the principle above, where we reduced a factor. Looking at this first expression, x plus 4 is a factor because it's being multiplied, and x plus 4 is a factor because it's being multiplied below. So can we reduce x plus 4 by itself? Yeah. X plus 4 divided by itself is 1. And our answer is x plus 1 over x minus 3. So this one would be yes, it illustrates the principle above.
Would you not like factor down the x's or no?
Good question. So if I look at the x's here, those are actually terms because they're connected with the plus and the minus. And any terms are like glued together with the expression next to it. In fact, anything in the numerator and denominator has invisible parentheses around it. So x plus 1 and x minus 3, I can't separate them. They're glued. And I want to just even illustrate this unless they're in parentheses or unless there's a times next to it.
Is that for every situation?
That's for every situation. And I always like to think of it in terms of numbers. Let's take a look at something that would represent kind of what this is. Think about this number. Let's say that I was to ask you to reduce 11 over 6 or simplify. Can you reduce 11 over 6? No, what if I wrote it like this? 8 plus 3 over 3 plus 3. You might think, oh, there's a 3 and a 3, but can I reduce those?
There's term.
Exactly, because there's 2, because 8 plus 3 represents one number. It represents 11. And 3 plus 3 represents one number. It represents 6. So I can't reduce anything. So here, reduce, I could say question mark, no, because you can't reduce values that have been plus or minus together, just like this situation right here. Okay, this is really, really important to today's lesson. So let's go ahead to the second one. 3x plus 1 over 3x minus 4. Does this illustrate the principle above? Can we reduce this?
No.
No, good, because these are connected. They have plus signs next to them or minus signs next to them. So no, I can't reduce that. How about the next situation? Can I reduce here?
Yeah.
Yes, good. The 3 is a factor. It's been multiplied. 3 divided by 3 is 1. So this would be yes, and that would equal x plus 4 over x minus 1. And this last one, x squared plus 1 over x minus 2. Can I reduce an x? No, good, because there is a plus sign here and a minus sign here. These are glued together. You could put parentheses around there. So this would be no, we can't reduce.
I mean, what if there was a parentheses and it was x2 and just x? Would it like
If it was like x squared over
just
2x, yes, because these are factors. This would be x times x, and that would be 2x, and now it's separated by multiplication. Let me use a different color pen. So then, yes, I could, which would be x over 2. Okay, but that's the difference, and you just noticed it. These are been multiplied. Those have pluses and minuses. Awesome.
So will we work with stuff like that?
We actually have already been working with stuff like this, but now we're going to be working with stuff like this.
Okay.
So now, yeah, it will be kind of mixed.
Okay.
All right, so here's really the important concept. You have to be able to understand well to be able to simplify today. Never, ever, ever, ever cancel terms. You guys know what terms are. You listed them on your quiz. Terms have pluses and minuses with them. Or you could say they're separated by plus or minus signs. You only, so never ever cancel terms, only, what do you think, what word do you think is going to go here? What can you cancel? Factors, awesome. Only factors. Factors are separated by multiplication. Separated by multiplication. Okay, so let's keep working with this concept. Now just focusing on polynomials. Write the following in lowest terms. So if I look at 3x squared y over 12xy squared, I could write it in factored form. This would be 3 times x times y over 12 is 4 times 3 times x times y. And hopefully you can see this principle illustrated well. I can divide 3 by itself and call it 1. I can divide x by itself and call it 1. What else can I divide? Y, good, y by itself. So my answer turns into x over 4y. Now you don't have to write out all the factors. Some of you might prefer to do it just within the context of the problem. You might see that 3 goes into 12 4 times, and x goes into x squared 1 time, and y goes into y squared 1 time. And then you still would have that answer x over 4y. So it's kind of how you prefer to work through it, but you do have to know that we can only reduce factors. All right, let's take a look at the next one. Let's see what you've learned. Can I reduce k over the k squared?
Yes.
Does it have a minus sign or a plus sign next to it? Yeah, we can't because it has that minus sign.
I thought it was 3 times k.
Ah, yes. If it didn't have that, then we definitely could, which is always good to think about. So we know we can only cancel factors. Caleb, can you put that away? Oh, are you typing it up? Did I call you out? And then, sorry, it looked like you weren't. Are you on the notes?
Yeah, I'm not ready.
Oh, I'm sorry. I'm embarrassed. I'm sorry, Caleb. I called you out on that. It seemed like you were doing something else, and I wanted to make sure that you were understanding it because this is brand new. So sorry about that. That's my fault. Okay, looking at this one here, we do know how to factor. We've factored a lot. So what's the first step in factoring? What's always the first thing we do? GCF, awesome. So if I look at 3K and 6, what would be the greatest common factor of those? 3, good. So I would take that out and I would have K minus 2. And then looking at the denominator, this I know can factor down. Hopefully you know. Turn to your partner and see if you guys can come up together. What does K squared minus 4 factor down into? Go ahead and discuss. Olivia, do you know what it would factor down into?
Yeah, wouldn't it be K plus 2 and then K minus 2?
Nice, you're amazing. Well done. All right, guys, my partner knew online. K squared minus 4, that matches A squared minus B squared, which factors down into A minus B times A plus B. So yes, this does factor down. And now that I've factored it, what do you guys see that we can reduce? Nice, the K minus 2. So then my answer becomes just 3 over K plus 2. So after we've done 2 examples, let's go ahead and define. How do we know that something is in lowest terms? A fraction is in lowest terms when there's no common factors left in the numerator and denominator. So lowest terms means no common factors exist in the numerator and denominator. All right, now that we have it defined, let's go ahead and try another one. So let's move down to this example here, 2p squared plus 7p minus 4 over 5p squared plus 20p. Oh, I see a p squared and a p squared. Can I divide that? No, why not? There's a plus sign. Good, it's a term. It's not a factor. So my next step of action would be factor it down. Yeah, and I always check for a GCF first. If I start with the numerator, is there a GCF? No. Yes, exactly right. Since it's a trinomial, I know that if it's factorable, it came from one binomial times another one. And I use that like strategic trial and error. The last term is negative. So am I going to have the same signs or different signs? Different, good. Undo the F. What times what would give me 2p squared? Good, 2p and p. And undo the L. What times what would give me 4? Yep, 2 and 2 or 4 and 1. Usually we choose 2 and 2, but here's where one of the tricks comes into play. Yeah, because I have a 2p here, Haley's right. I don't want to put a 2 in with it because there is no GCF. Good, so we're going to use 4 and 1. We won't put the 4 in with the 2. We'll put a 1 here and a 4 here. And how do I know if I have it correct? Check the OI. And Caroline noticed that if I have negative 8p plus 1p, that will create a negative 7p, which is the opposite of what I want. So good, we'll switch the signs. Make this one a minus and this one a positive. And now it'll check out to be positive 7p. All right, looking at the denominator. First step always is look for a GCF. So good, there's a 5p here. If I was to factor this, I could see this is 5 times p times p. And if I was to factor 20p, I could see that that's 4 times 5 times p. So they share the 5p. I'm going to take that out. And I'd be left with p plus 4. And now there is something that I can reduce. Allison. Nice. And that would come out to be 2p minus 1 all over 5p. Well done. All right, we simplified rational expressions. Now we're going to move into multiplying rational expressions. But before we do that, let's make sure we review how do you multiply two basic fractions. We can multiply straight across. So we can do 4 times 3, which is 12, 5 times 2, which is 10, and then reduce. What goes into both 12 and 10? 2, which would create 6 over 5. Or can someone raise their hand and tell me what's a different way I could have multiplied or simplified this rather than going that route? Does anyone know a different way I could have gone about this? And I do need to give a road to excellence. I'm going to be picking today. So raise your hand. Katie. Well done. 2 goes into itself 1 time, into 4 2 times, and then I could just multiply across 6/5. Both of these work. This way we'll probably use more today. So make sure you can see how that works, that we can reduce in that way. Nice job, Katie. And let's move on to using that skill for the next one. Multiplying. Let's see if we can reduce what we have. So looking at the 7 and the 14. What goes?
2.
Good, 2. 7 goes into itself 1 time, into 14 2 times. So if you want to look at it like that, yep, you could say 5a goes into itself 1 time, and it goes into 15a 3a times. You could also look at it separately. You could say, how many times does 5 go into 15? 3. And then how many times does a go into a squared? A goes into itself 1 time, into a squared 1 time. Then we multiply across and we have left 3a over just the 2. All right, on to the next one. Hi. Somebody's in the doorway and I'm not sure who they're looking for. Do we know this person? Oh, I don't know. What'd you say? I don't think so. I think it was a student. Haley, did you need me to go back to this one?
Yeah.
Do you want me to do it in a different way?
Yeah, can you like explain it again?
So the other way that you could look at it is 15a squared is really 5 times 3 times a times a. And this one's 5 times a. So I can see that 5 and 5 are shared, and a are shared. And so I have that 3a left over. And then the 7 and the 14. 14 is 7 times 2. So I can reduce that, and I have just that 2 left.
Okay.
All right, let's take a look at the next one. Oh, I see an X and an X. Feels good. Can I cross it off?
No.
No, they have a minus sign with them and a plus sign. So what do I do? GCF, good. So if I'm looking at 5x minus 15, what do those share? 5, good. So we would take that out, and that would leave us with x minus 3. If I look at the denominator, 3x plus 9, what do both of those share? 3, good. So I would take that out, and that would leave me with x plus 3. Looking at the second fraction, what's the GCF of 4x and 12? 4, good. So we'll take that out, leaving me with an x plus 3. And what's the GCF of the denominator? 6, good. So I'll take that out, leaving me with an x minus 3. Now I can start reducing factors. Can I reduce the x minus 3s? Yep. They just cross off. Any number divided by itself is 1, and when you multiply, they eventually go on top and bottom, so they cancel. X plus 3 and x plus 3 cancels. Is there anything else that we can reduce? 5 and 6, no. 3 and 4, no. What about 4/6? Yeah, 4 over 6 reduces to 2/3. So I can say 2 goes into 4 2 times, and 2 goes into 6 3 times. Mario.
Just to confirm, they didn't cancel out, wait, do they cancel out diagonally or?
Yeah, diagonally. You can cancel out diagonally or up and down with multiplication. Then I multiply across and I get 5 times 2, which is 10. 3 times 3, which is 9. And we get that 10/9. All right, we have simplified. We've multiplied. The last thing we need to do is divide. But let's go back to a basic division of two fractions. If I have one fraction divided by another, turn to your partner and the person with the, I'm going to be basic, the most siblings, you turn and tell them what you would simplify this to. Olivia, do we have the same amount? No, I think you have more than me. You have 3, right?
Yes, I have 3. Yes, 3.
You have 3, right? Yes.
Yeah.
Okay, Olivia, do you know how we would take this fraction divided by this fraction and simplify?
Yes. So wouldn't you flip the 2/3
Nice.
to 3/2?
Awesome.
And then you could simplify the 4 to a 2 and the 2 to a 1. And
Nice.
then you multiply across and it would be 6/5.
You're amazing. Well done. Thank you. All right, guys. Yes, have a good one. Have a good one. The process that we need to do is multiply the second one by its reciprocal. Then it turns into multiplication, so we can reduce across or up and down. And the answer becomes 6/5. All right, let's use that skill with polynomials. So looking at this next one here, we have t minus 2 divided by 8 divided by a second fraction. To simplify, we're going to keep the first one. Don't flip the first one. I've seen people do it and they get the wrong answer. Only flip the second one. So we're going to multiply by the reciprocal. So we have 6 over t minus 2. What can I reduce then? Good, t minus 2, t minus 2. And then what do 6 and 8 share? 2. Good. So 6 divided by 2 is 3. 8 divided by 2 is 4. So my answer becomes 3/4. All right, let's do this last one together. And then the other two I'll have you kind of practice either on your own or with a partner. Okay, looks scary, but we can make it less scary by factoring. So let's take a look at this first fraction. Well, we know that we're going to have to multiply by the reciprocal, right? We've done that. So we have to multiply by the reciprocal, but I'm going to go ahead and factor this while I kind of do that work. So if I look at 2k squared minus k minus 1, if I factor that down, it's a trinomial, so I know to jump to 2 parentheses. The last term is negative. So am I going to have the same or different signs? Different, good, plus and minus. Then I undo the f. What times what would give me 2k squared? 2k and k, good. And then undo the L. What times what would give me 1? 500 times 1,000. Actually, the answer is 1 and 1. And how do we know if we got it right? Check it. So we have the outside is negative 2k plus the inside is 1k. Negative 2k plus 1k is negative k. That works. On to the bottom. The bottom, there's no GCF, so I'm going to break it into 2 parentheses. The last term is positive, so am I going to have the same or different signs? Same as the plus. Undo the f. 2k times k would give me 2k squared. Undo the L. 3 times 1 would give me 3. If I put the 3 here and the 1 here, then it will OI correctly. It'll check to the 5k. Now the second one, I have to multiply by the reciprocal. So I'm going to go ahead and flip it and factor it in the same step.
We have to factor, oh wait, no, you can flip it then factor it.
You could do it in either order. You could factor it, then flip it, or you could flip it, then factor it. You just have to do both. So I'm going to do it in one step. I'm going to flip it, but I'm going to factor as I go. So if I'm factoring 2k squared plus k minus 3, the last term is negative. Should I have the same or different signs? Different, good. 1 plus 1 minus. Undo the F. 2k times k would give me 2k squared. And undo the L. 3 times 1 would give me 3, but I'll have to make the 3 positive and the 1 negative to add up to a 1k. And then lastly, I'm going to take 4k squared minus 1, and I'm going to factor that. Just want to make it's not a trinomial, so how are we going to factor 4k squared minus 1? We've done it before. It's the a squared minus b squared. Nice, Peter. So it's going to become 2k minus 1 times 2k plus 1. And now I can start reducing. Let's see what we can reduce. Can I reduce the 2k plus 1? Is there one diagonally to it or up and down? Yep, diagonally. How about the k minus 1? Is there one diagonally to it or up and down? No, and I love that you guys know that k minus 1 is different than k plus 1. We cannot touch those. How about the 2k plus 3? Yep, we can reduce that. And now I can go ahead and multiply across. So I have k minus 1 times k minus 1. I could save ink and call that k minus 1 squared. And then the denominator would be k plus 1 times 2k minus 1.
You can only cancel out if
The exact same.
no, I mean, they can only it's not really.
You mean if they're up and down?
Yeah.
Yes, I can't cancel out those k minus 1s because they're across. Good question. And I box it. And I finished it.
How's your sister?
The pregnant one? She's actually in labor right now. It's been so hard not to check my phone. And she is like,
Check your phone.
she's in labor. My mother-in-law texted me 30 minutes ago saying she's pushing, but they haven't given me a picture yet. So I'm like waiting. I'm like, it's not there yet. Okay. All right. Okay, guys, we got 2 more to try. So I'd like you to turn to your partner. Try this one together. You're putting it together now, multiplying or dividing. And let's have the person with the least amount of siblings now. You start this one. Say what you would do. Oh, that's me. Okay. Okay, Olivia, the last term is negative. So I'm going to go ahead and factor that down. And the last term's negative. So I'm going to do different signs. Plus and minus. R times R would give me R squared. 2 times 3 would give me 6, and I'll make the 3 positive and the 2 negative, so I'll add up to 1R. And then if I factor this bottom one, the last term's negative. So I'm going to have different signs, 1 plus 1 minus. I'm going to undo the F. So R times R would give me R squared. And then I'll undo the L. So that would be 6 and 2, which would add up to 4R. And then it's division, so I want to make sure I multiply by the reciprocal. So I'm going to do R minus 1 over R plus 3. And then I'll cancel some things. So R plus 3 and R plus 3. And then R minus 2 divided by itself is 1 also. And so we get that answer of R minus 1 over R plus 6.
Why is it? For the flipped. Can you show me what I did?
Yeah.
Like I got a similar answer. I just didn't get the plus 6. Like what did I do?
R plus 2 or minus 2 R plus. Oh, because you used 4 and 3. But if I check the outside and the inside, that will add up to 1R, not 4R.
Okay, so be
So I need to do
3 and
6
4.
and 2.
Oh, and you 6 and 2.
Because it can't be 3
Okay.
and 4 because that would either make a 1R or a negative 1R.
Okay.
All right, guys, let's take a look when you're finished.
It should be R minus 1.
Did you get R minus 1 over R plus 6? Yeah. All right. This last one, is it division? No, it's multiplication. So you're not going to flip the second one. Go ahead, try this one on your own. I'm going to do a walk around, see if you need help.
From my friends. I was like, there was one that like watched like older song parodies. So. Christmas one.
They're just so they're just so I bet part of them come up like I'll see it, like maybe even like have a dance for it.
Okay, stop. Now I know why.
Oh.
That was weird.
Oh yeah, I think this is
I was like, so.
no, now I say differently. This is.
What did I do wrong?
You notice how many M plus two are? So I got like a ton of M plus twos and they just all.
So here's what happens, if you add
It's gonna be 4 and 1.
Yeah. I have a. Do I like put this as one term and then I cancel it?
Can I cancel
Yes,
that?
yes.
Because they were like one was here, one was here.
You can still do that, yeah.
And then do I, can I reduce?
Not anything.
Yeah.
Those are connected.
All right, guys. The answer was M plus 6 over M plus 3. Let's take a look. We should have had M plus 1 times M plus 2 over M plus 1 times M plus 4 times M plus 6, M plus 4 over M plus 2 times M plus 3. And then I see some pieces cancel. I have M plus 1 and M plus 1, M plus 2 and M plus 2, M plus 4 and M plus 4. And that's where we get to that M plus 6 over M plus 3.
And we do not simplify that.
We can't because they're connected with those plus signs. So yeah, that's as far as we can go. All right, guys, good work today. We were going to start the critical thinking, which is conceptually some pieces that you really need to know well for the test, but we have Friday and Tuesday. So I'm going to save it for Friday and give you some time to work on homework. You guys did so good. Like, yeah, staying engaged. So let me give you some homework time. I'll pull up the book and yeah. All right. So I will record the video and you can watch that.